The cardiovascular and circulatory systems. What is the heart? To start, there are three types of muscle cells in the body: smooth, skeletal, and cardiac. However, we'll be focusing on the cardiac muscle cell today. These are special tissues that are some of the hardest working cells to be found in the body. The cardiac muscle cells are unique because they are only found in the heart. The heart is one of the most hard-working muscles in the body. It's continuously pumping blood to every corner of your body 24 hours a day, 7 days a week, 365 days a year. Wow! If it didn't, well, we would die. So good job, heart. Keep up the great work. The heart is a biological superorgan. It is extremely consistent and incredibly fatigue resistant. How does it function? Well, before going into depth about the anatomy of the heart, let's introduce a few vocabulary words. An artery takes blood away from the heart. The vein takes blood to the heart. Got it? Easy. There are 4 chambers of the heart that are involved in the pumping of blood throughout the body. The right atrium and ventricle is responsible for receiving deoxygenated blood from the body and for pumping the blood to the lungs in order to oxygenate them again. The left atrium and ventricle is involved with receiving the newly oxygenated blood from the lungs and then sending it back to be circulated in the body once again. The superior and inferior vena cava are the primary veins responsible for bringing blood to the heart. The blood is then sent through the pulmonary artery, bringing it directly to the lungs, where it will be involved in the exchange of gases, releasing CO2 to be expelled by expiration and receiving oxygen. The blood then heads to the pulmonary vein to be reintroduced to the heart before being forcefully pushed out through the aorta and then to the rest of the body. There are 2 types of cardiac muscle cells: autorhythmic cells and contractile cells. The autorhythmic cells are responsible for keeping the pace of the heart and is adjusted for any kind of stimulus placed upon the body in order to maintain homeostasis, which will be discussed more in depth later. The contractile cells are unique in a way that the length of muscle is restricted in order to allow for greater force and fatigue resistance. Why do we need it? We need a heart to continuously supply the rest of the body with ample amounts of oxygen for cellular respiration. Aerobic respiration requires the use of oxygen in order to generate the necessary components for the majority of ATP production in the electron transport chain. The use of circulating the body also allows the body to get rid of any toxins in the blood by passing it through the liver and kidney. Your body is continuously seeking to correct any changes that would involve the increase of your heart rate beyond resting rate. This process is known as homeostasis, which is the stabilization of anything physiologically deviant from the normality. This includes, but is not limited to, heart rate, body temperature, and blood pH. Your heart beats faster or slower depending on stimulants placed on your body by either yourself internally or by external factors. Some examples of this would be exercise, being too hot or cold, dehydration, anxiety, etc. Your body is also capable of preemptively increasing heart rate prior to a workout in order to begin sending a larger supply of oxygen to skeletal cells. Increasing exercise would require a greater demand of ATP and in turn greater need for aerobic respiration. As temperature changes, your blood vessels constrict or dilate and your heart will pump faster in order to cool or warm up the body. Alright y'all, it's time for vocab review. Homeostasis is something we already knew. Regulation of the body's physiological process. Examples of this are shivering, sweating, you know the rest. Aerobic respiration, in the word we need to breathe, catch a breath and make energy with ease. Let's look at what energy we see. It's a form of energy currency. Give me the name, that's right, ATP. The heart needs help to move blood around. Arteries move blood away from town. Veins bring blood back to the heart. Get ready, it's about to start. Deoxygenated means no O2 for you, fool. Oxygenated minus the D, got oxygen for me. Cardiac muscle, this guy will never tire. Ideal worker, the other muscle types admire. Heart does its job, it always beats. Whether you're awake or asleep, it'll keep going till you're 5 feet deep. The right atrium and ventricle takes in blood on the DO. The next stop is the lungs, where we'll get oxygen, son. The left A and V deals with sending blood back to the body. This is part 1 of heart anatomy. Vena cava is the name of the main vein. Remember the definition, it's like a transport cart responsible to shoot blood back into the heart. Pulmonary artery directly shoots to the lungs to release CO2 by due expiration. So please expose me to the needed oxygenation. After blood goes back to the heart, we can see everything together plays their part.